Okay, so let's see. The first thing we need to do is, read the problem. But there's 120 students, and they're recorded in the bar graph below. But we're asking another 80 students to select their favorite sport. Based on that information, how many more students are likely to select football rather than baseball? So the first thing we want to do is figure out what percentage of the students chose football first, and then what percentage of the students chose baseball. So it seems like for football, about 42. So 42 out of 120. So what percentage is that? That is 35%. So about 35% chose football And then for baseball, about 28-ish. So 28 out of 120 is about 23%. So that's how many people chose that sport. Now we need to take that information and we're going to just figure out how many are out of that 80. So what's 35% of 80? So 35% of 80 is 28. So that means 28 people will choose football. Okay, and again, we did that by doing 35% times the 80 people. And then we have 23% times the 80 people. And that's going to give us 18 will choose, roughly 18. Well, we can make it 19. 19 will choose baseball. Now, how many more students are likely to select football? So then we just subtract. Well, it's 28 minus 19. Approximately 9 more students will choose football rather than baseball. Okay, let's look at the next one. So this one's a lot of information, so I want you to take a minute and just kind of read that over and take a guess at what you should do. So kind of think it over, pause, and try to solve this. So before we solve this, some key things here is that this graph shows the entire week sales, but we want what's sold during one day. Also, these are each day up here. So the first thing I would do is add all of those up. When you add all of those up, you get 2,100 cookies, okay? And we want to know chocolate chip versus oatmeal. So we want chocolate chip versus oatmeal. So I'm going to figure out what percentage of this 2,100 is that 40%. So I'm going to do 2,100 times 40%. And when I do that, I get 840. And then when I come down here and do oatmeal, I'm going to do 2,100 times 15%. And I'm going to get 315. Now, again, what's important to remember about these numbers is that this is what's sold per week. So we need to figure out how many are sold each day. So now we're going to take these numbers and divide both of them by 7. So 840 divided by 7 gives me 120. 315 divided by 7 gives me 45. And I want to know how many more cookies will likely be sold. So I do chocolate minus oatmeal, and I get about 75 more cookies. And that's a day. Okay, so now let's look at the next page. So let's look at the next page then. Now the first thing we have is some definitions. We're going to go over these. We kind of talked about those in the first lesson. But so the first one is lower extreme. So the lower extreme of a box and whisker plot. And that's your minimum value. Okay, and what that means is the leftmost whisker. So let's take a moment and draw a box and whisker plot. So we're just going to draw 3 lines kind of spaced out. Now we're going to make those lines into a box. Now you're going to draw points on opposite sides of your box and then just extend lines out to them. Now our first one is this lower extreme, and that's this point here. This is your lower extreme. The next one we have is the first quartile. We've kind of talked about this first quartile. And that's also called your lower quartile. And that's your left edge of your box now. That's the left edge of our box. So this is our first quartile or our lower quartile. I'm just going to write LQ for lower quartile. And that's mostly how I'm going to reference them: lower extreme, lower quartile. The next one is the median. That doesn't really need an explanation. That's the middle number, or it's also called your second quartile. And in this case, it's the middle line of the box. It's the middle line of the box. So that means this is your median there, that middle line. The next one is our upper quartile. Our upper quartile. That's also called our third quartile. And that's our right edge of the box. Right edge of box. Our upper quartile in this case is here, your upper quartile, that one. Last but not least is our upper extreme. So our upper extreme. That's also your max value. So the maximum value of the data. And that's this dot here. So that's our rightmost whisker. What I kind of want to point out that we kind of maybe glossed over is that each section is worth 25%. So each section of this data, so from here to here, that's worth 25%. Each box is worth 25%. And this last portion is also worth 25%. And that's because we're breaking it into fourths: quartile, quad, fourths. So each section is worth 25%. And that means in between my lower quartile and my upper quartile is 50% of my data. So in between them is 50% of my data. So now let's talk about stem and leaf pods. So they are what is right below us in example 1. That's what a stem and leaf pod looks like. So the stem is the left digit. It is usually the tens digit. So remember, in a tens digit, if the number is 15, your tens digit is that number 1. If the number is 205, then the stem would be 20. Okay. The leaf portion is your right digit. And that's normally your ones digit. So again, in those two examples, in 15 and 205, my leaf portion would be 5 and 5. Okay, so now let's look at example 1. Okay, so it gives you this key here. That's going to helpful, right? This line in between. The stem is 1, the leaf is 3, so it reads as 13 points. So what's the median number? So we simply just need to find the middle number. So if it helps, cross them out. This one, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. It's in between two numbers, so I add up the two numbers. Both of those numbers are 24. You divide by 2, and you get 24. Okay? So same way, you just look at the information. It's already ordered in least to greatest, so that's pretty simple. Then you just find the middle number. Okay, let's look at example 2. It's the box and whisker plot. So I'm first going to label what things are. So this is my lower extreme. This is my lower quartile. This is my median. This is my upper quartile, and this is my upper extreme. So to find the range, remember, is the biggest number minus the smallest number. So that means we're going to take our upper extreme and subtract our lower extreme. So our upper extreme is 100, and we're going to subtract our lower extreme of 60, so our range is then 40. Okay, this next one says, what's the best estimate, emphasis on best, of percent of students scoring greater than 92? So remember, we said that each portion is worth 25%. So it doesn't have to look uniform, right? We're not saying each portion is 25. We're saying each represents 25% of the data. So that means 25% of the data is in between 60 and 64, or from 68 to 92. So that's a big range there, but it just depends on what your data looks like. So what's the best estimate storing greater than 92? So we're going to look at 92 and look at greater. So that's only 25% of our data is greater. Mr. Ali, the teacher, wanted more than half, more than 50%, to score 75 or greater on the test. So I want you to do C on your own and then look at it. Okay, so pause, do C, and now look at it. Okay, so hopefully you know that the median is the middle number. So 50% would be here at 68. Okay, so half of the students scored higher than 68. They did not score higher than 75. 75 is somewhere around here, which we don't know what percent of the data that is. Okay.